Well, welcome everyone to another episode of Heat Treat Radio. I'm Doug Glenn. I'm your host of Heat Treat Radio, and I'm also the publisher of Heat Treat Today magazine, which, by the way, you can subscribe to if you'd like at www.heattreattoday.com/subscribe. I'm looking forward to our conversation today with Fernando Carminholi. Fernando has extensive experience in the chemical specialty products industry for surface finishing, focusing on industrial parts cleaning, metal pretreatment, and functional electroplating. Fernando and I are going to be discussing various aspects of parts cleaning, which should be very interesting. And obviously, parts cleaning is an integral part of many thermal processes. But before we start, Fernando, I want to mention that this episode is being sponsored by Hubbard Hall, who, believe it or not, are celebrating 175 years this year, which means they were founded in 1849, which is pretty impressive. You'll hear more about Hubbard Hall later on in this episode, so stay tuned to that. Or you can go to their website at www.hubbardhall.com on the web. So with that, Fernando, just want to welcome you to Heat Treat Radio. And I would like to start just by asking you, so start off with some fundamentals. Let's start off with some parts cleaning basics. Do all parts need heat treated? Why do we do cleaning? And what are the risks of not doing the cleaning?
All right. Hey, Doug, thank you. Thank you for having me. Thanks for having this opportunity to talk with all the subscribers about cleaners, about what is the importance to clean. And actually, we can talk more later, but we're going to focus on the cleaning before the heat treat. But also, there's
Yeah.
a cleaner after the heat treat when you remove quenching agents. But all right, let's talk about before heat treat.
Yeah.
So you ask if parts need to be cleaned, and my straight answer to that is yes, and it could be maybe as well. I will explain maybe why the maybe. Maybe is because some really light oiled parts with light oil, it goes to the furnace and there is not a problem. And then it happened on this industry. I would say that maybe 10% of all the parts he treated, clean that was he treated does not clean any kind of operation.
Yeah.
Um, yeah, 10% goes straight. It came from stamping or deep drawing and go for the furnace.
Yeah.
But the rest, the 90%, it will require cleaning, and that's exactly what we're going to talk today.
Yeah.
Uh, on the rest, I would say that maybe 35% will pass through a solvent cleaning, and which, when we're talking about solvent, we're talking about two different ways to clean parts. One is the very old and well-known technology that is the open top degreasers,
Okay.
that you have your solvent in a tank, in a proper tank, and then you have like a, some chillers on top to hold the vapor. It called vapor degreaser as well.
Yeah. Mm-hmm.
Yeah, you see a lot of machines on the market from 80s, from 90s already. And another way to use solvents, it's in a closed vacuum machine,
Yeah.
right? Which is more, I would say, more technological, more updated machines. And the rest of these, I would say that more than 50% they're cleaning in water-based cleaners, which could be in a spray application, it could be in a spiral tunnel, it could be as immersion. And normally, I mean, so what kind of oils we clean? So I would like to say one thing with all the as soon as the year is passing, you have a new regulation for the oils and
Yeah.
all the modernization. And every year they have like they on the R&Ds, they work with newer kind of oils.
Hmm.
Cooling fluids, rust inhibitor, uh, forming lubricants, deep drawing compounds, and they could be synthetic. And you know, every year has become more difficult to remove. So
Yeah.
that's the big challenge for who got the cleaning operation.
Right. I assume the solvents have to keep up, as it were, with the changes in the chemistry of the cleaners.
Sure, sure. Both of the system, the solvents and the aqueous as well.
Okay. Okay. So you're saying then, if I'm hearing you right, Fernando, you're saying that probably 90+% of parts in the heat treat process are cleaned. Maybe 35% of those get solvent based, and the rest perhaps aqueous based. Um, are there I've heard that the reasons why we clean are
Hmm.
various. Obviously, if you're going into a vacuum furnace, there's different reasons why you clean than if
Right,
you're
right.
going into an air and atmosphere furnace, right? I mean, you're wanting to make
Exactly.
sure you don't drag in all those contaminants into a vacuum furnace. I mean, that's why you clean, basically, right?
Right, right.
Or at least
But
one reason why.
exactly. But most will be more like atmospheric furnaces,
Right.
and then what do you drag? And most of the customer were talking about high volumes, and it moved high volumes for inside the furnace. I mean, let's think in two different ways. If you don't clean at all,
Yeah.
or you have a bad cleaning, what can bring as a defect? What is the problem?
Yeah. What
I would say,
happens?
what is the problem? What happened? So if you don't have cleaner at all, like I said in the beginning, if it's really light clean, light oil, a light oily part, uh, and you don't drag that much oil, it could not be a problem.
Right.
But if you, yeah, let's think about a big operation with lots of oil, maybe like fasteners or kind of part that you have like some ways to carry more oil to the furnace. So it will produce a lot of drag, you know, oil to the furnace. It will burn.
Yeah.
So you will have certainly a furnace contamination
Yeah.
that will contaminate the oxygen, the carbon. It can cause discarbonization. It can, this effect can affect the hardness, the mechanical properties of the parts as well. And obviously, I think that the easiest way to see, you will see a lot of smoke.
Yeah.
So
Exactly.
is
Yeah.
it common?
Yeah,
Yeah.
it is common. It is common. And I guess one other thought I had on this one, Fernando, is not only will it affect the parts potentially, but it can actually impact. I want to see if you agree with this. It can impact the life of your
Oh,
furnace, right? Because you're getting a lot of contamination. It's going to need more maintenance, and you can actually damage your
definitely,
furnace. Yeah.
definitely. Yeah, yeah. It
Okay.
will have more maintenance. It will shorten the life for the furnace. It can cause other effects like with the smoke inside the furnace, you have uneven heat distribution inside the
Yeah.
furnace.
Good point.
It can lead to like a warping, cracks, inconstant hardness on the part, and that's something that it could be, yeah, it could be the fact of no cleaning at all.
Right.
And
Right.
yeah, and now, I mean, if you look it up for the another way, you have the cleaner. You have a machine cleaning somehow solvents or water based, and somehow you're not cleaning well the parts. You can drag more than oil to the furnace. You can drag more other compounds. Not that much on the case of the solvents, but on the water based cleaners, you can drag the rinses together with all the chemicals,
Right.
and you have a different areas like if you think about nitrating or FNC operations, and then you have like a bad cleaning, areas that you clean well, areas that you don't clean well. You can think like when you use a sunscreen on the beach. It's like it's a little bit the opposite, right? The
Yeah.
parts, the area with the oil will suffer, some
Yeah.
soft spots, unformed hardness.
Yeah.
It can bring surface defects like pitting, stains.
Right. It's
Also,
almost like unintentionally using a stop off paint on
exactly.
your part if you've got the oil.
Exactly, and then you see a couple areas that is well treated, and couple areas that you
Yeah.
see
Yeah.
that the structure is not as expected.
Yeah. Yeah. Okay. So that's good. I just want, I mean, that's very
Good.
basic, but I want people who maybe have not dealt with uh, parts cleaning in the past just to hear some of these things. I mean, the reason not all parts need part cleaned, a good number of parts do. If oil on the surface or contamination or spottiness on the finish of the part is not an issue, then you may not need to wash. But a very large percentage of parts that are heat treated do get washed, and they get washed in either solvents or aqueous based, water based solvents, and that's good for the life of your furnace, for the interior furnace, for the maintenance of your furnace, as well as for the properties of the parts. So that's good. That's what I wanted to hit on that first question. But I want to move on to second topic here, really, and that is one that I thought would be very enlightening to some of our more experienced parts cleaning people, and that is, and maybe you can bring an expertise to us on this area, Fernando, and that is the area of legislation that Hubbard Hall is aware that it's going to be coming down the pike that we need to be aware of. So, can you talk a little bit about the legislation regarding parts cleaning
Okay.
and
So
standards?
yeah. I mean, when we're talking about legislation, everything that the APA stated, we're really close to this to the industry, to all the regulation. I can, it's a lot of different topics. Like, let's separate again in two different topics:
Okay.
water based and the solvent based.
Okay.
Um, okay, when we're talking about water based cleaners, you have to watch out for what kind of raw materials you're using, what is the cleaner formulation. Because if you don't rinse well, that's something that you need to control in your process. If you don't rinse well, uh, you're gonna dragging a lot of those materials, and that can cause all the problems that we're already talking about. But talking about legislation, for water-based cleaners, the legislation, I would say that is less problematic. And then, for example, you have some restrictions with some surfactants,
Yes.
NPEs based by, like, for example, nonylphenol ethoxylated. Uh, all those new formulations, I would say that they're already free of. And another big topic to discuss, and this is something that everyone is talking about now, it's PFAS and PFAS contain products.
Okay.
It could be in both of them. It could be in the cleaner based on water. It could be on the solvent.
Well, now, what are those things? What are those two things that you mentioned, if you don't mind?
The PFAS and PFAS is all the fluorinated compounds, which is you have tons of compounds. You see a lot of those in, like, on the Teflon based, in a fire extinguisher foam, in a lot of different things in the industry.
Okay.
Those are non-forgiving. This is forever. They call forever chemicals.
Forever
That's
chemicals. Okay.
so far there is not a good stable way to treat and eliminate those chemicals from even the drinking water. This
Okay.
is something that all the industry is regulating, how to analyze, how to you get the analysis, how to treat, how to waste those chemicals as well.
Yeah.
Because some of those compounds, we're talking about PPT. which is part per trillion.
Yeah.
It's a really low amount, easy to have in different ways. Maybe it's, it contains in the drinking water in the lower amounts, but this is something to watch out on the chemicals. This is something that it's already suffering restriction, and it's a hot topic.
Fernando, are these restrictions, these let's say rules that are coming down, are these federal based rules? Or are these state based rules, or what?
No, those are federal. If you look it up for PFAS, all the surface finishing word, all the wastewater word is talking about that. I mean,
Okay.
if you go, even you go to the Congress, a lot of regulatory from the government talking about to have the same, maybe different states with different numbers. This is
Yeah.
something that is already, it's defining the rules, and defining how to analyze and how to treat.
Right.
But the thing is, for example, Hubbard Hall is already PFAS free
Okay.
manufacturing. We decided to do not working on this way. Uh, Talking about regulation, I would like to switch gears a little bit here, which
Yeah.
the regulation, normally we talk more about the solvents. So the solvents, we're talking about methylene chloride, about TCE, trichloroethylene, perchloroethylene, and propyl bromide. Those are the halogenated solvents that they already on the list. They are working. EPA is working on this already. If you don't mind, I have a cheat sheet, some numbers here on my computer. I would like
Yeah.
just to bring it up.
Yeah.
Um, if you go on the Hubbard Hall website, definitely you can find it. You go for application and surface cleaning and solvents, you're gonna find this table that we're talking about different solvents. When the APA rule was the rule was stated. For
Yep.
example, methylene chloride, that's already finishing. uh, the rule was dated in March 24, and
Okay.
all the companies, they have until March 26 to do
To
not use
to
this
comply.
solvent as a cleaner.
Okay. Yeah. So that
So
chart, we'll pull that chart up on our screen when we're doing this
sure,
segment. But
sure,
it's that chart's on your website, and that's so people can go there to find out.
easy, yeah, yeah.
I,
This is a I would say this is we took all the regulations and put in one table for
oh, okay.
different solvents. When is what is the exceptions? For example, if you use for NASA or federal usage, you have a little bit more time. But for
Okay.
TC, you have 1 year counting by January 25. It means
Okay.
January 26, you're not going to be able to use the TC as a vapor degreaser.
Okay.
Uh, but there are some alternatives for that, and
Yeah.
that's what I would bring it up a little bit, though. Uh, if you're using a open top machine, uh, there is a alternative that's fluorinated solvents, which is low global warming potential, non-flammable. Those are stable products.
Yeah.
Those are available on the market. And also the other alternative is actually is the best choice is the modified alcohol.
Modified
Those are
alcohol. Okay.
modified alcohol. Yeah, this is a formulated alcohol. It's not a only a I would say not a bulk solvent. It's a formulated product, and you have a good cleanability. It's a good permeability. Because that's the beauty of the solvent. It can go between the parts or inside of the holes to clean everything.
Yeah.
And so to and modify alcohols, they just can be used in the vacuum cleaning machine. It will work, fairly almost the same as the vacuum furnace. It will, but on the cleaning side, you
Right.
have all the equipment running in a vacuum, and you have a distillation process that will remove oil and the water from the part from
Yeah.
the
Yeah. So, Fernando, I'm curious, that chart that we were looking at. What percent? I'm just curious how important this is for our listeners. As you know, most of the people that read our
Mhm.
stuff and listen are
Sure.
manufacturers who have their own in-house heat treating. Right. Obviously, we get a lot of commercial heat treaters too, but our core audience are those manufacturers who have their own in-house heat treat. How many of them do you think, as of right now, and I realize this is a pure speculation question, right? How many of
Hmm.
them right now do you think are using uh, either solvent or water-based solutions that are going to be basically ruled out by these
Yeah,
regulations?
I would say that today's 20% used today halogenated solvents that need to be ruled out and switch it for
Replaced
another technology. 20%. That
20%.
that's that yeah that's the number. In some states, for example, New York, Minnesota, this is already in place.
Yeah,
They cannot use it's getting more and more, but the final date, the date rule to be enacted, for example, for TC, for trichloroethylene, which is really common, it
yeah.
would be January of 26. I mean, the
Okay.
unique one that is proposed yet, it's not on the final discussion, is the NPB, is the N-propylbromide. This is, I think, that will take between 3 and 5 years to be with all the restrictions.
Okay. Okay. So I guess it's safe to say that there's a significant number of people out there currently who are using cleaning solvents that will, over the next 3 to 5 years, be
Definitely,
outlawed. So they need to start looking at
definitely.
yeah.
I,
Okay.
and I would like to bring a red flag right now.
Okay. Yep. Wave the flag. Wave the flag. Yeah.
Because if you're working with some product that it will be restricted, and you need
Yeah.
to change,
Yeah.
or you use the same equipment, but as I told you, the fluorinated solvent, it will be 3 to 4 times more expensive.
Okay. Gotcha.
Okay. And on the other side, if you're gonna buy equipment and to use modified alcohol, uh, there is not that many equipment manufacturers, and
Okay.
that's the limit. If 20% of this market use, and they need to change, they will expect to change on the 6 months before. I would say that today you have equipment manufacturing expecting to deliver equipment in 6 months.
Yeah. Yeah. You need to. Yeah. People need to keep in mind the lead time, that they're not going to be able to
Right.
get that equipment that quickly. So, very good.
Exactly.
Very good. Let's take a quick break. We're gonna hear a little bit more about Hubbard Hall, and who's obviously sponsoring today. We'll take a quick break, and then we'll be back right after the break to talk a little bit more about the pros and cons of aqueous versus solvents and a few other things. So let's take a break real quick, and we'll be right back.
My name's Molly Kellogg. I am sixth generation family member at Hubbard Hall. I'm currently president, CEO, and chairman. Apothecaries Hall was founded in 1849, and it was named that after the manner of the old guilds. And I think that's important as we look at the history of the company, because it talks about an insistence on craft, on excellence, on service. And as I look 175 years later to who we are today, I feel like we still embody those same founding principles and that same ethos, that we want to serve our local communities, we want to serve our customers, and we want to do it in a way that embraces technology, whether it's the best horse-drawn cart of 1849, or now we've got trucks on the road delivering our chemicals.
Okay, welcome back. So let's jump in. Let's jump in a little bit, Fernando. Talk about the pros and cons of using aqueous versus, or that is water-based versus solvent cleaners. If a person doesn't know the difference, what's the difference, and why would we choose one over the other?
Very good. So this is a really extensive debate.
Okay.
You can see some videos at the Hubbard Hall website talking about this. What I see in the market is companies that's selling only solvents. It will always talking, bad thing about the water-based companies that sells only water-based products, talking bad thing about the solvents and regulations. And I would say that Hubbard Hall plays on the both sides. We understand what is the best usage for different application. So I will try to go on the really high level,
Yeah. Can't get into a lot of detail.
explaining,
Right.
yeah, how we're gonna decide to, hey, I am on the solvent side, I need to keep on the solvent side, or I need to go for a water basin. So first of all, you need to understand what is the contamination. What kind of oil? We're talking about the cooling fluid, rust inhibitor, deep drawing. It's a lot of heavy chlorinated oil, or it contains sulfur or not, or it is a polar basin. It could be polar and non-polar. That will decide what kind of solvent or water-based product you're gonna use. So normally, when you have a I would say hydrocarbon oil-based, it tends to be easier to remove with solvents.
Okay.
When you have a water-based cooling agents, or rust inhibitor, that's easier to remove with a water base. This is one thing to consider. But it doesn't mean that if you have a hydrocarbon, you cannot remove with water. Um, Another thing that you need to take a look is what is the part geometry that we're talking about.
Yeah.
This is a flat part, easy to remove in a spray, or you need a ultrasonics to remove, or this is a lot of blind holes, and parts will be really close of each other. I mean,
Right.
that's an advantage to go to the solvents here, because the solvent trains, even if you use a really good surfactant, which will change the surface tension, the solvent trains to have a much better permeability. That's the term,
Yeah.
to go on the and clean on the really deep holes, and when the parts is really close off each other.
Yeah.
Uh, Another thing to consider is I would call overall the EHS. That means, what is the company it's open to use inside the factory.
Right.
Hey, do I need VOCs? Do I need do or I need to avoid? Aqueous normally, it's not normally, but Aqueous it's a VOC free. And
Right.
solvents you need to check. It's how flammable is the solvent as well.
Right.
When we're talking about, I would say, waste, let's go for another spectrum. Talking about waste and footprint, what is the difference between the systems? Uh, the footprint for solvent is smaller, because everything that you need is the degreaser machine, open top, or vacuum cleaner. But you clean, you dry. Normally, the drying process is way easier on the solvent,
Right.
and you don't have all the other process needed on the water basin. So all the waste generated on the solvent that you have is maybe if you have some water that came from water-based uh, rust inhibitor, or even the oil, or even some cleaner that's already done. You will have this weight, and then you send for a partner that will pick it up and take care of the waste. In the Aqueous, this is different. You will need rinses. You will need a temperature to dry.
Right.
You need blowers. You need heaters. The ovens maybe to dry the parts. And that's a problem. If you leave the water behind, it can lead to corrosion, for example.
Yeah.
So yeah, that's a big difference between solvent and the water basin.
And this may be simple. I want to make sure that I'm accurate on this, and that maybe this will
Hmm.
be helpful. I mean, the reason the solvent is not an issue so much with the drag out, let's call it, where you keep part of the cleaning solution on the products, because it's because of evaporation, right? I mean, it evaporates.
Right.
The solvents evaporate much quicker than the water
Y-
evaporates.
Yes, but for example, that's right. And that could be a problem as well. That's
Yeah.
why old vapor open top vapor machine could be a problem,
Yeah.
because the limits they're tightening every year, by the APA.
Yeah.
When you have a old machine that is not, you have the chillers on the top. What happened is you have the vapor phase, you heat it up your solvent, you have the solvent, and then you have the chillers, the coil to condensate back. That's how it works.
Right.
If the chiller is not working well, it's gonna, like you said, the
Yeah.
solvency, it will go to the atmosphere. On the end, when you take it out your part, it will dry up really easy. When you go for the closed system, you don't have this emission.
Right. Yeah. Fluid
That's the
coming out. Yeah.
difference, and that will be another big difference between solvent and water based, because when you have a machine based on the solvent, you fill the machine. I would say normally we're talking about 5 drums, 10 drums of product, and
Right.
the consumption is really low, right? The consumption is low. Normally, customers spend like 1 drum every 2-3 months. Depends on the system, but
And you
this is
said
how
that was for solvent or for aqueous?
that's for solvent.
Solvent.
That's
Okay.
for acres. You need all the rinses. So that's every time that you're running a load, you go to the rinse, you drag solution out
Yeah.
of your
Yeah.
tank. So that is the consumption will be higher for the water basin.
Right. Right. Okay. So as far as uh, variable cost, the potential is that maybe your aqueous system might have a higher operational cost. You think?
I, that's another good debate. The
Yeah.
operational costs need to include the equipment as well.
Well, that I was going to ask about the difference between capital equipment costs. I'm assuming you said the
Exactly.
solvent is smaller footprint. Is that the same as saying it's a lower price?
Yeah, I would say, for example, for the acres, if you need to include a ultrasonic, for example, that
Uh-huh.
because you need an enhanced uh, um, way to use the waves to clean the parts.
Yeah.
Of course, it will increase a little bit the cost,
Sure.
but normally the cycles on the water base is lower. You can produce more parts. If you have, for
Okay.
example, maybe you're cleaning parts in a plant is already having a wastewater system. That's another point to bring it up on this conversation.
Yeah.
You will need to treat the water. Maybe 1-2 gallons per minute, depends what is the flow rate on the
Sure.
rinses. And this water you need to be treated before dumped to the sewage,
Right.
and you need to follow the regulation
Yeah.
and the limits. if you don't have, so you will need on the waste on the water basin, but on the cost overall, you depend of the parts. Really depends of the parts, because every day, that's another thing to understand. If we'll start to talk about cost, you know, it's a big difference. I would say not that long time ago. If you're thinking before COVID, water used to be cheap.
Yeah. Yeah.
Energy. So now water is very expensive. Energy is very expensive.
Yes. Yes.
Waste is very, very, very expensive. So and then if you take all this, rework is unacceptable. And that's the thing. We we call that, cleaners can be cheap,
Yes. Okay.
but poor cleaning always is expensive.
Yeah.
I'm thinking with the same head of, the owner of the operation. The cleaning process will be cheaper than, you have a heat treated part, or even the steel, or grinding or blasting. If you take the overall cost, cleaning is nothing. But
Right.
if you don't do the best that you can do, it can cause a huge problem and
Yeah.
reward. And that's one thing to put in mind.
Right. Right.
Uh,
Product failure, most notably. The more critical the part, the more important, obviously, to make sure it's cleaned well.
yeah, yeah.
So
Then
there's
and
no. So is it safe to say there's no clear winner here when we talk about cost of equipment versus cost of operation? There's really no. There's not a clear. Well, aqueous is obviously less expensive.
yeah, depends. It really depends on the parts, and
Yeah.
what is the level of cleanliness that you want, and
Right.
what kind of oil you're using. Because if you have a part that cannot be uh, used in the acres, I would say, because there's a lot of holes and you need to clean inside the holes, and
Yeah.
or another reason that parts are together, are welded,
Tightly
and then
packed. Yeah.
there is no comparison. But you can bring it up a lot of factors and put side by side.
Yeah.
uh, solvent, there I would say that it's the chemical consumption, it could be more uh,
Yeah.
expensive, but acres you need a more equipment.
Yeah.
But when you're talking about the vacuum cleaning machine, it will be a substantial capital
Capital
for the
expense.
equipment now. Yeah, depends on the equipment. It would be over $1 million.
Yeah. Yeah. Well,
Which,
go ahead.
yeah, I'm sorry. I would like just to bring it up one thing. I'm
Yeah.
I'm seeing equipment manufacturers for the washing machine, vacuum washing machines. They're looking out for the market, and they see the problem of the mix of oils and coolings, and you can use, like they call, hybrid system, which you go first for a water based, on the same machine.
Okay.
Use a water based fluid, and then go to the solvent fluid on the
Okay.
same machine.
Okay.
Yeah, that's a new feature in the market.
Okay, that's very interesting. So it's a hybrid piece of equipment. It starts with an aqueous wash and then finishes up maybe with a solvent washer.
Yeah, exactly.
Okay, very interesting. Very interesting. All right, well, let's move on to the fourth and final topic. I guess I want to wrap up this third thing that we're talking about as far as the pros and cons of aqueous versus solvent. Just to say that I'm sure that Hubbard Hall, if a listener has questions about which system makes the most sense for them, then I'm sure your team there at Hubbard Hall can help them answer that question. So recommend people get a hold of you guys if they've got
The,
questions about which system makes the most
yeah,
sense.
the best way to evaluate is, we see the picture today. We see what you have as a cost. What is the pros and cons that you have today, What
Yeah.
is your timeline to change? If
Yeah.
you're solvent regulated, for example, and we can do a scenario after. How much you're going to spend in a new line if you need a new line. We
Right.
do have a like prototype lines that we can running some tests, different cleaners,
Okay.
or solvent or open top machine. We can run different scenarios and see about the cost, what
Right.
is more environmental friendly solution,
Right.
because and that's the point, going to this question that you brought for environmental friendly.
Right.
uh,
Which is, by the way, the last question I do want to ask you. I want to just talk about the cleaning process. How do we make it more efficient, profitable,
yes.
and environmentally friendly? So fire away.
So how the chemical manufacturers look it up for in different ways. Let's start for the solvent. Like I told you, there is a feel. It's a really low drag out, but also the solvent. It is depends on the solvent, especially talking about modified alcohol. Uh, all the oil that you bring on the parts, it could contains uh, product that will change. I would say change the pH. I will the for the chemical, and it could go really acidic, or it
Right.
could go really alkaline.
Alkaline.
That will screw your machine. That
Yeah.
will attack your. So you lost the solution. You can have problems with the seal casket. You can attack the parts if you go acid. So there's some ways to extend the life, and then you can analyze the solvents. You can put some stabilizers to continues use the same solution,
Yeah.
because comparing this fairly new technology, I would say 10 years ago, the the chemical manufacturers, they have way better stabilizers to handle those new kind of oil that we mentioned, to extend the shelf life or the life of the solvent as much as we can,
Right. Right.
and that's a big saving. On the aqueous side, on the water basin, what can be done? Like, think that the problem here, why you dump your process, it's because the oil as well. So Hubbard Hall does work with a feature, which is one equipment. It's a piece of equipment that is a membrane filtration. We built this equipment internally. We sold for many customers already.
Okay.
We this this technology is more than 40 years already on the market. It's well
Yeah.
um,
Yeah.
tested. What this technology do is it filtrates the solvent. I'm sorry. It's filtered the oil out of the cleaner.
Right.
So that will extend the life of the cleaner. I will give one example. We do have a customer that the parts are, some um, brake calipers
Okay.
that
Yep.
they need to dump the cleaners every 2-3 weeks.
Okay. All right.
All right, and it's a new field of so it's a cost to put chemicals, is a cost to treat. With the membrane filtration, it's a more than 5 years without dumping the
Ah.
solution.
Okay. Very interesting.
Yeah, yeah, and we understand that it recovers like 98% of the cleaner and
Yeah.
filter out all the oil that you don't need, all the emulsified oil. This is something that could be done, and this is change a lot the cost. So that's why a lot of variables that we need to put on the equation. So that's why I really ask, if you for the subscribers and people that is listening, if they have this problem on the hand, if you're looking for the solution, we're more than happy to jumping, evaluating what you have, see what is the value add of one system or not, or another, and comparing costs.
Yeah, that membrane system the membrane filtration system you were talking about, does that work on both solvent and water based?
No, it's because normally the solvent, they have the distillation process.
Yeah. Okay. Gotcha. Yeah.
Okay, the distillation will separate the solvent, the water, and the oil.
Yeah. Gotcha.
The membrane will work only on the water basis, and when you use product that will emulsify the oil.
Gotcha.
When you say emulsify, means when you have the cleaner, you have the solvent that is able to mix the oil and the water,
Yeah.
like you see in the milk. For example, you
Yeah.
have like 2% of fat. That's the same because it's yeah, it's emulsified.
Yeah. Gotcha. So sounds good. Sounds good.
Good,
All
good.
right. Well, Fernando, I think that wraps it up for what I wanted to cover. I really appreciate your time. Appreciate your time. Appreciate you being here.
Thank you so much. Thank you for this opportunity. I hope that all the subscribers that you know understand a little bit better and more clear how important is the cleaning process
Yeah.
before the heat treat.
Yeah, yeah, for sure. And if people have any questions, please feel free to get a hold of Fernando. We will put up on the screen at this point in time any of the contact information to get a hold of Fernando directly. If you're listening and you're unable to watch, you can feel free to always email me and I can put you in touch with Fernando. My address, of course, is doug@heattreattoday.com. If you have a specific topic you would like to hear us cover on Heat Treat Radio, we're always happy to take suggestions on future topics. We like to cover stuff that's of interest to the listener. So please feel free to email me with suggested topics. That's doug@heattreattoday.com. Obviously, we would like to thank Hubbard Hall for sponsoring this episode, and you can find out more about Hubbard Hall on their website at www.hubbardhall.com. And if you enjoy Heat Treat Radio, if you don't mind, whatever listening platform you're on, please give us a high rating, 5-star, only stellar comments about how great it is, so that it can, so we can hopefully gain new listeners and things of that sort. And as always, this and every other episode of Heat Treat Radio is the sole property of Heat Treat Today, and may not be reproduced in part or in whole without advance written permission from Heat Treat Today. And you can find out more about Heat Treat Today, as I mentioned, by going to www.heattreattoday.com/subscribe if you would like to subscribe to our monthly print edition, any one of our 7 e-newsletters or podcasts. You're more than welcome to subscribe there. Appreciate you listening. Again, I'm your host, Doug Glenn. And again, thanks. Hope to see you next time.